serial order problem, first of all, is not so much a problem as it is actually a reflection of our ability to produce adaptive actions. But the question is, how is it that we string together different movements so that they become actions that we actually want to perform? And Carl lastly proposed that rather than this being a sequence of reflexes, people actually rely on more higher level planning that is more intentional in nature. Now, of course, you got to give some arguments for why that may be the case. And lastly was actually very diligent in doing so. So in his paper, he actually gives 4 good reasons to think why sequencing actually relies on higher level planning. And I'll go through these one by one. So first of all, deafferentation does not prevent sequencing. Now, this may not mean anything to you right now, so let me explain what that actually means. Deafferentation happens to people when they get damage to their spinal cord. And they can get this damage to their spinal cord sometimes due to a virus, actually. That happens more often than you would like to think, but it does. Or due to some sort of external damage, meaning they get into some sort of injury, some accident that then leads to injury that can actually cut their spinal cord right at the top, right at sort of the base of their neck. And oftentimes what happens in this case is that actually not the full spinal cord gets damaged, but it's really just the sensory input part, meaning people don't get input from the rest of their body anymore, but they can still send commands to their muscles from their brain. So the spinal cord, if you want to think of this in a somewhat simplistic way, has 2 different streams to it. One that goes from the brain to the body, and that is sort of the stream that deals with signals that then control contractions of the muscles. And then there's also sensory information that comes in from the body so that the brain actually can feel what the rest of the body is doing. So when people have deafferentation, they don't get, or at least if they have the version of it that's called sensory neuropathy, they specifically have damage to that sensory stream. They don't feel their bodies anymore. And so that's an interesting question or an interesting condition, because if you want to think of sequences as chains of reflexes, well, supposedly these reflexes are reflexes to sensory information coming in. So if it's now the case that people don't get sensory information from their body, then it should be that they shouldn't be able to produce sequences of movement that are under their control in some sense. And it turns out that if you take patients like that and you throw some units on their fingers that can record their movements very precisely, and you put them in a pitch black dark room so that they also don't get any visual information about what's going on, you can then ask them, hey, could you draw a circle or a square or a figure 8? And as you can see here from these recordings, those patients are actually able to do that. So what that suggests is that purely based on commands that are sent from the brain to the muscles, people can create these movement patterns even in the absence of sensory information. So that strongly argues against the idea that sequences of movements are just sequences of reflexes to sensory information. So that's the first argument. Now, a second argument is that if you look at movement sequences and how quickly people can produce them, people can produce movement sequences much more quickly than they should possibly be able to if this was all based on feedback. What I mean by this is that, of course, when you produce a movement, the brain sends commands to the muscles then contract and start doing their thing. Then sensory information from those movements comes back in, and then that goes back up to the brain. That whole loop takes a while. And it should be that if sequences are just reflexes, then you shouldn't be able to move any faster than whatever it takes for that reflex loop to come back. Well, if you look at very skilled typists, or, to have this more up to date, if you look at how fast a lot of you guys can actually text messages on your phone, the speed at which you can do this is much faster than would be possible if this were all just based on reflex. So the current record, for example, for texting is that somebody can actually write a very long text that you see here, complicated one as well, this whole text in 18.45 seconds, which means about 9 characters per second, meaning that's about one letter close to every 100 milliseconds. Now that's about twice as fast as a reflex loop would take in order to produce that kind of movement pattern. So that's again another strong argument against the notion that sequences of movements are just reflexes. A third argument is pretty obvious, right? The same response can be followed by different responses. So what this means is, if I'm walking, it should be according to reflex chaining that, if I've taken one step, now I get sensory information back, and that sensory information should then determine what my next step is going to be. Well, in reality, I can decide right now to get up and decide to go walk to my kitchen, to my living room, to my dining room, and it's not clear if everything is based on reflexes, why it is possible that I can make these particular decisions. So that's another issue that Lashley raised as an argument against reflex chaining. And then the last one, which I'll go into detail about in the next video, is that if you look at the types of mistakes, the errors that people make when they produce action sequences, those errors are typically not random. They actually reflect that people had some sort of plan in mind, but maybe just applied the right plan to the wrong object or something like that. And I'll elaborate on that more in the next video.